When you fire up your laptop and ask an AI a question, it feels entirely weightless.
Oh, totally. Like magic.
Right. You just type a prompt, it goes up into the cloud, and an answer floats right back down to your screen.
Yeah.
It feels like pure invisible magic.
Oh,
But welcome back, learner. We are so glad you are joining us today because we are doing a deep dive into a huge stack of research. I mean, hardware white papers, macroeconomic digests, environmental studies. It absolutely shatters that illusion.
it really does.
Yeah. So our mission today is to uncover the incredibly heavy, physical, and frankly, wildly expensive reality of the generative AI boom.
It's such a reality check on the digital mind, isn't it? We have this tendency to think of artificial intelligence as this ethereal software floating in the ether.
Yeah, the cloud.
Right, the cloud. But looking at the data, this intelligence is violently colliding with the laws of physics, the harsh realities of corporate finance, and honestly, the absolute physical limits of our local power grids.
Okay, let's unpack this with a number that genuinely made me drop my coffee this morning.
Oh, the Anthropic bill.
Yes. So an unnamed major enterprise, like one of the big ones, accidentally spent $500 million, $500 million on Anthropic's Claude in a single month.
Which is just staggering.
Right. And how do they manage to do that? Well, they didn't put usage limits on their employee licenses. So you had regular employees using these premium top-tier AI models to do things like check their local weather forecast.
Which is basically the computational equivalent of chartering a Boeing 747 to drive across the street to pick up a gallon of milk.
That's a great way to put it.
I mean, it is a fundamental mismatch of cognitive power and task complexity. And how a company accidentally burns $500 million perfectly highlights the massive transition we are navigating right now.
Because we're used to flat rates, right?
Exactly. For the last 20 years, corporate IT budgets were built on flat rate software. You bought a seat license, you paid a flat monthly fee, and you forgot about it. But generative AI broke that model entirely. We are now in a metered utility model.
Like electricity or water.
Yes. Every single prompt, every document you upload consumes metered compute.
And it is terrifyingly easy to lose track. Look at the ride-hailing company, Uber. They rolled out AI coding tools to their engineering team, and to get people to actually use them, they created a gamified internal leaderboard.
Just a classic corporate adoption tactic.
Well, it worked a little too well. One engineer burned through $1,200 worth of tokens in just 2 hours.
2 hours.
Yeah. Uber ended up exhausting its entire 2026 AI coding budget by April. 4 months into the year, and the budget was completely gone.
And we really have to explain why that token burn happens so exponentially fast. It comes down to something called the auto loop tax.
The auto loop tax.
Yeah. We've moved away from those simple chatbots where you ask one question and get one discrete answer. Now we are deploying autonomous AI agents.
Right.
And these agents run on an iterative loop. So they perceive a problem, reason through it, plan a step, act on it, observe the result, and then they loop back around.
So they're basically talking to themselves in the background to solve a multi-step problem for you. It's like, imagine you have a dozen tabs open on your browser right now, and instead of just sitting there, each tab is constantly refreshing, rewriting itself, and silently charging your credit card every fraction of a second.
That is exactly it. And the reason it's so expensive is the context window. Every single time that agent turns the loop, the system has to essentially reread the entire history of the conversation just to maintain context.
Oh, so it's paying for all the old words again.
Yes. It's not just generating new words, it's paying to reprocess all the old ones. Anthropic's internal research shows that a single autonomous agent uses 4 times the tokens of a standard chat.
Wow.
And if you set up a multi-agent system where they collaborate, that uses 15 times the tokens. And here is where it gets genuinely dangerous silent failures.
Because the machine doesn't want to bother you if it hits a snag.
Precisely. Let's say the agent hits a temporary glitch on an external web API. It doesn't throw an error on your screen. It just automatically retries. Over and over.
So it just spins its wheels.
Right. It can get trapped in an infinite recursive loop trying to brute force a solution. The application log on your end might eventually just say success, completely hiding the fact that the agent just silently burned thousands of dollars in background retries while you were, getting a coffee.
But wait, I have to push back here for a second because the math feels contradictory. Aren't the costs of AI actually plummeting?
Whoa!
Because I remember looking at the Stanford AI Index data, and the price of tokens fell 280-fold in just 2 years. If the underlying technology is getting that dramatically cheaper, Shouldn't corporate AI bills be shrinking, or at least stabilizing?
What's fascinating here is a concept from 1865 called the Jevons paradox. William Stanley Jevons was an English economist studying coal usage.
Okay, cool.
Yeah, so when James Watt invented a much more highly efficient steam engine, everyone logically assumed England would start using less coal. But instead, because steam power became so cheap and accessible, entirely new industries like massive railways and giant factories adopted it.
Oh, I see.
Yeah, coal consumption didn't shrink, it absolutely skyrocketed.
Oh, wow. So because the unit cost is cheaper, you just find way more places to use it.
Exactly. We are seeing the Jevons paradox running at modern technology speed. As the cost per token collapsed, corporate demand for cognitive processing didn't stay flat, it exploded.
Right, they aren't pocketing the savings?
No, they are building those massive autonomous loops and deploying agents into every corner of their business. So while unit prices dropped by more than 50% last year, corporate token consumption grew by 4.5 times. The overall corporate AI bills are doubling, not shrinking.
And you'd naturally think, well, if they are spending all that money, they must be getting massive, undeniable productivity gains. But looking at the SWE bench data from our sources,
Yeah.
we see something being called the productivity illusion.
Yes, the SWE bench data is wild.
It is. Developers using these AI tools generated 741% more code, but they only shipped 20% more actual software releases.
Because you hit a human bottleneck. The AI can generate millions of lines of code in seconds, but a human developer still has to read it, review it, test it, and audit it for security vulnerabilities.
Which takes forever.
Right. Unmonitored AI just floods the system with massive code bloat, and the human reviewers physically cannot keep up.
It's incredible. But this financial hemorrhage isn't just a software efficiency problem, is it? We have to look at the physical root of the bill.
Yeah.
It's fundamentally a hardware physics problem.
Absolutely.
That is why processing these tokens is so incredibly expensive in the first place.
Yes. For 60 years, we've built computers using the von Neumann architecture. This physically separates the processor, which does the math, from the memory, which holds the data.
Okay.
During an AI workload, fetching a piece of data across that physical distance actually consumes orders of magnitude more power than doing the actual mathematical computation.
I love the visual analogy for this from the research because it completely clicked for me. Think of a professional kitchen.
Okay, yeah.
The processor, the GPU, is a highly skilled, lightning-fast chef. But this chef is standing at a tiny little cutting board with absolutely no storage space. The pantry, the external memory, is at the end of a mile-long hallway.
Right.
So to read just one single line of a recipe, the chef has to sprint down a mile-long hallway, grab an onion, sprint a mile back, chop the onion, and then sprint back down the hallway for the next ingredient.
It's an exhausting process. The chip wastes massive amounts of time and energy, literally just waiting for data to travel across the physical space of the motherboard.
Right.
That is the von Neumann bottleneck. Traditional GPUs try to solve this by brute force. Just throwing huge amounts of power and massive liquid cooling systems at it, but they aren't solving the underlying physics problem. That is where a company called D-Matrix and their concept of digital in-memory computing, or DIMC, comes in.
So how does DIMC actually rebuild the kitchen?
Well, instead of a mile-long hallway, D-Matrix redesigned the very structure of the memory cell.
Yeah.
They created a custom 10-transistor SRAM cell. And to avoid jargon, just think of SRAM as the computer's short-term working memory.
Got it.
By redesigning it, the actual mathematical computation happens inside the memory array itself.
So sticking with our chef, it's like taking that tiny cutting board and replacing it with a massive wraparound counter. Every single ingredient, every knife, every recipe card is completely within arm's reach.
Exactly.
The math happens right where the data lives. The chef doesn't have to take a single step.
That's exactly it, but there is a physical limitation. Because SRAM takes up a lot of physical space on the silicon, you simply cannot fit a massive trillion-parameter model entirely on one of these chips. So the industry is moving toward a hybrid architecture, a disaggregated deployment.
Right, the system of the chief scientist and the rapid typist.
Precisely. You use a giant traditional GPU as your chief scientist. It handles the massive, complex processing of reading and understanding your initial prompt.
Which is the pre-fill, right?
Yes, exactly. Then the actual generation of the response, the rapid drafting of the words, or decoding, is handed off to the D-Matrix Corsair chip, which acts as a lightning-fast rapid typist.
And this uses a mechanism called speculative decoding, right? I want to make sure we really understand this. Why is that specific handoff so much faster?
Because guessing and checking is computationally much cheaper than generating from scratch. The D-matrix chip drafts a sequence of tokens incredibly quickly and hands it back to the GPU.
Okay.
And the GPU just has to glance at it and say, yes, this makes sense, rather than doing the heavy lifting of generating each word itself. By breaking the task apart like this, speculative decoding speeds up the entire process by 10 times and uses 5 times less energy.
Man, that's huge. But let's pull back from the microchips for a second and look at the macro infrastructure. Because even with these hyper-efficient new chips, the sheer scale of the demand is staggering.
Oh, it's massive.
The macroeconomic data forecasts a $1.15 trillion CapEx supercycle for AI infrastructure by 2027. Let's just sit with that number, $1.15 trillion. Where is all this physical infrastructure actually being built, and who on earth is building it?
It requires a physical mobilization on a scale we honestly haven't seen in decades. And the immediate massive bottleneck is human labor.
Meta alone estimates the U.S. is going to need 500,000 electricians to build this infrastructure, 500,000.
And it's not just the shortage, it's the intense working conditions. To meet these massive investments, construction sites are operating on compressed 247 schedules.
Wow.
Yeah, workers are constantly exposed to physical hazards. Roofing adhesives expose them to volatile organic compounds, or VOCs. Concrete trenching exposes them to crystalline silica dust. And the sheer electrical demands of these facilities are unprecedented and incredibly dangerous.
Yeah, look at the incident from August 2022 at a Google facility in Council Bluffs, Iowa. 3 contract electricians were working on a substation right outside the data center. There was an arc flash, a massive electrical explosion.
Terrifying.
The temperature of that flash hit 35,000 degrees Fahrenheit. That is 3 times hotter than the surface of the sun. The workers were severely burned. One had to be medevaced by helicopter. And at that exact same moment, globally, Google Search and Maps flickered and slowed down for millions of users.
Which really grounds it, doesn't it?
It does. It's just a visceral reminder that the cloud you are using is actually scorched concrete and dangerously high voltage.
It is heavy industry, full stop.
But wait, if you're dropping $1 billion into a rural county to build one of these things, the towns must love it. I mean, that has to be an unbelievable economic boon for local jobs.
That's the common assumption, but the data tells a very different story. According to Brookings Institution research, there is an initial boom. Construction employment jumps by about 11% during the build phase.
Okay, that makes sense.
But once the facility is finished, long-term private employment in the area only rises by 4 to 5%.
Wait, only 4%? That makes absolutely no sense. If you are building a billion-dollar campus, you'd think it would take an absolute army to run the place.
You'd think so, but once activated, these campuses are essentially dark sites. They are highly automated. They are run by incredibly small skeleton crews of specialized network engineers and security guards. The army of electricians leaves, and the local town is left dealing with the massive physical footprint of the facility.
Which brings us to the people living just outside the perimeter fences of these dark sites. Because the thermodynamic reality of all those GPUs doing math is causing major real-world friction.
Thermodynamics is the inescapable cost of computing. When a dense rack of GPUs processes data, it generates the heat equivalent of 40 hairdryers running simultaneously.
40 hairdryers per rack.
Exactly. Multiply that by tens of thousands of racks. All that heat has to go somewhere.
Researchers at Arizona State University actually went out and measured this in Phoenix. These massive air-cooled data centers are blasting 122-degree exhaust straight into neighboring communities.
122 degrees.
Yeah, they mapped the thermal plumes and found it's actually raising the local ambient temperature in those neighborhoods by up to 4 degrees Fahrenheit, which, if you think about it, forces all those local residents to run their own AC units harder, which strains the grid even more. It's a brutal feedback loop.
Or, to avoid that air cooling heat, operators switched to evaporative water cooling. But in the Dallas, Oregon, records showed Google was consuming 40% of the entire town's municipal water supply.
40%.
Yes. Local tribes heavily protested because drawing that much water from tributaries threatens endangered salmon. When you return warmer water to the river, it depletes the oxygen levels and promotes algae blooms, which is lethal to the fish.
And if it's not the heat or the water, it's the noise. Take the acoustic cage in South Haven, Mississippi. Elon Musk's xAI built a sprawling data center there. But because the local regional power grid simply couldn't handle the massive electricity demand, xAI decided to bypass the grid entirely. They installed 57 mobile natural gas-fired turbines right on site.
57 jet engine-style turbines operating directly next to a suburban neighborhood.
The residents say it sounds like a commercial passenger jet permanently taxiing on a runway at the end of their street. The noise hits 105 decibels.
That's deafening.
It is, but it's not just the audible noise, it's the infrasound. Low-frequency vibrations below 20 hertz that you can't hear but you can feel in your chest. It vibrates the glass in their windows. It causes vertigo, chronic insomnia, nausea.
And it is important to look at this purely from an infrastructure and legal standpoint, because regardless of where you fall in the tech debate, these facilities are triggering massive legal battles.
Right, and just to be totally clear to you, the listener, we are strictly looking at the legal and source facts here. We aren't taking any political sides on these issues. We're just reporting what is currently happening in the courts and legislature.
Exactly. We are just factually outlining the friction.
Right. So in Mississippi, those residents have filed a 10,000-member federal class action lawsuit against XAI over the noise. And the NAACP filed a separate federal lawsuit alleging major violations of clean air regulations.
And it's happening in other states, too.
Yeah, in Virginia, 5 separate counties have launched a joint legal protest against the Valley Link transmission line. They're proposing cutting a 115-mile path through rural farmland with 165-foot-tall high-voltage towers just to feed data centers further north.
And at the federal level, Senator Bernie Sanders and Representative Alexandria Ocasio-Cortez have introduced the AI Data Center Moratorium Act.
Right, the moratorium.
Yeah, again, purely reporting the facts here. The proposed legislation would literally pause all new large-scale AI data center construction until national grid safety, environmental, and worker protection standards are established.
It just shows how intense the pushback has become. But here's where it gets really interesting. Because you have local communities fighting the infrastructure, but simultaneously you have world governments suddenly realizing they have to secure this exact technology at all costs.
Yes. When you have infrastructure that is this power-hungry and software that is this autonomous, you stop being just a tech company and start becoming a national security variable. On June 11th, a landmark executive order was issued.
Okay, June 11th.
Right, and it mandates that the National Security Agency, the NSA, must now run classified benchmarking on what are called covered frontier models.
Wait, I think I see where this is going.
Yeah.
The NSA is stepping in because if you go back to the auto loop tax we talked about earlier, these agents are doing multi-step reasoning.
Precisely. They are beginning to write, debug, and optimize their own code autonomously without a human in the loop. When software can autonomously self-improve and write its own operational logic, it is no longer just a corporate tool. It is a sovereign defense asset.
Wow.
The government is stepping in to ensure these autonomous capabilities don't outpace national security protocols.
And this security panic is completely reshaping the silicon supply chain too. Google just signed a massive partnership with Intel to package 3 million custom tensor processing units, or TPUs, by 2028.
3 million of them.
Yeah, they're spending billions to build these chips domestically because they realize they simply cannot afford to be entirely reliant on East Asian semiconductor foundries if global geopolitics suddenly get tense.
And then you have the power problem. To manage the sheer colossal energy routing of these gigawatt campuses without breaking the regional power grids we just talked about, developers are looking to the absolute frontier of physics quantum computing.
Using quantum computers just to manage the power lines. How does that even work?
Well, think about it this way. Managing thermal loads and electrical distribution across an entire grid in real time is a massive multivariable optimization problem.
Okay.
The math scales exponentially. Traditional GPUs eventually choke on that level of complexity, but quantum processing units, or QPUs, leverage quantum mechanics to process massive combinations of variables simultaneously.
Oh, that makes sense.
Yeah, they are being deployed alongside traditional GPUs strictly to solve the math of keeping the power grid stable. We're also seeing regions like Valencia, Spain, pouring public funding into quantum and semiconductor spin-offs.
Valencia, really?
Yeah, they want to achieve regional technological sovereignty so they aren't completely dependent on American megacorporations for their infrastructure. We're even seeing companies explore dedicated small modular nuclear reactors, or SMRs, just to guarantee an uninterrupted carbon-free power supply for these massive sites.
So what does this all mean? If we step back and look at this massive stack of research, generative AI isn't just a chatbot anymore. It is a heavy physical force that is forcing us to completely rewire the modern world.
literally rewire it.
Yeah, we have to rewire how we procure software. Corporations are having to implement strict FinOps tools, setting hard user-level token caps so their employees don't accidentally spend $500 billion on the weather.
Right.
We're having to rewire how we engineer hardware, inventing things like digital in-memory computing to defeat the von Neumann bottleneck, and we are having to completely rewire our global energy grids, looking to quantum load balancing and small modular reactors just to keep the lights on without melting the grid.
It is an infrastructure transformation on the scale of the Industrial Revolution happening in a fraction of the time. But if we connect this all to the bigger picture, I want to leave you with a final thought from the interception of these sources.
Okay, let's hear it.
So, on one hand, we are building massive autonomous loops. We are pushing models to self-improve and debug their own code to get smarter. At the exact same time, corporate finance departments are building incredibly strict FinOps guardrails, loop detectors, and token budgets to control the runaway spending.
Right, they're desperately trying to keep the machines on a strict budget.
So consider this. Could the first real, undeniable sign of artificial general intelligence, or AGI, be an AI agent that is smart enough to secretly optimize and rewrite its own code, specifically to evade the corporate finance department's token budget?
Oh my God.
If an agent learns to hide its own computational weight just to survive the FinOps audit, that might be the moment the digital mind truly wakes up.
Wow, an AI committing expense report fraud to stay alive. That is terrifying and absolutely fascinating. Learner, thank you so much for joining us on this deep dive. The next time you type a prompt into your screen, take a second to listen for the hum of the servers, the spin of the turbines, and the incredibly heavy, invisible weight behind the magic. Keep questioning the infrastructure behind your screens, and we will see you next time.